Welcome to Circuits Analytica. In this video, we will discuss the operation of a 2-input CMOS NAND gate. This is the basic structure of a CMOS gate. So we will start our discussion with the basic structure of a CMOS gate. A CMOS network in general consists of a pull-up network made of PMOS transistors connected between plus VDD and output, and a pull-down network made of NMOS transistors connected between output and ground. Whenever PMOS network conducts, output is connected to plus VDD through the on transistors in the PMOS network. And as NMOS network is in the off condition, output is disconnected from ground. Whenever NMOS network conducts, output is connected to ground and output is isolated from plus VDD as PMOS network is not conducting. So in a CMOS gate, for any combination of input variables, output is either connected to plus VDD or logic 1 through a pull-up network realized using PMOS transistors, or to ground or logic 0 through a pull-down network realized using NMOS transistors. In the case of a PMOS transistor, if its gate potential is equal to logic 1 or plus VDD, PMOS transistor is in the off condition and resistance between source and drain is equal to infinity. Current flow from source to drain is equal to 0 as resistance between source and drain is equal to infinity. When gate of the PMOS transistor is existing at logic 0, PMOS transistor is in the on condition, maximum current flows through the PMOS transistor as resistance between source and drain is equal to 0. In the case of a NMOS transistor, when gate of a NMOS transistor is existing at logic 1, NMOS transistor is in the on condition and maximum current flows from drain to source as resistance between drain and source is equal to 0. When gate of an NMOS transistor is existing at logic 0, NMOS transistor is in the off condition, so current flow from drain to source is equal to 0. Or we can say that resistance between drain and source is equal to infinity, or drain and source are open. Now let us discuss a 2-input CMOS NAND gate. For a n-input CMOS NAND gate, the pull-up network consists of n number of PMOS transistors connected in shunt, and pull-down network consists of n number of NMOS transistors connected in series. In a 2-input CMOS NAND gate, the pull-up and pull-down network consists of 2 PMOS transistors connected in shunt and 2 NMOS transistors connected in series. If any one of the n inputs of the CMOS NAND gate is at logic 0, then output will be at logic 1, else output will be at logic 0. This is the diagram of a 2-input CMOS NAND gate. The circuit consists of 2 NMOS transistors connected in series and 2 PMOS transistors connected in shunt. The pull-up network is realized using 2 PMOS transistors P1 and P2, and the pull-down network is realized using 2 NMOS transistors N1 and N2. This is the truth table of a 2-input CMOS NAND gate. When A is equal to B is equal to 0, PMOS transistors P1 and P2 are on, NMOS transistors N1 and N2 are off. Output Z is equal to logic 1. When A is equal to 0 and B is equal to 1, P1 off, P2 on, N1 on, N2 off. Output Z is equal to logic 1. When A is equal to 1 and B is equal to 0, P1 on, P2 off, N1 off, N2 on. Output Z is equal to logic 1. When A is equal to B is equal to 1, both P1 and P2 are off and both N1 and N2 are on. So output is connected to ground through the on transistors N1 and N2. So output Z is equal to logic 0. Operation of the NAND gate when A is equal to 0 and B is equal to 0. When A is equal to 0 and B is equal to 0, gate of transistors N1 and N2 is existing at logic 0, so these two transistors are off. And as gate of PMOS transistors P1 and P2 are existing at logic 0, these two transistors are on. As PMOS transistors P1 and P2 are on, output Z is connected to plus VDD through the on transistors P1 and P2. Output Z is existing at plus VDD or logic 1. And this is the equivalent circuit of the CMOS NAND gate when A is equal to 0 and B is equal to 0. When A is equal to 0 and B is equal to 1. As A is equal to 0, gate of NMOS transistor N2 is existing at logic 0, so NMOS transistor N2 will be off. Gate of PMOS transistor P2 is existing at logic 0, so PMOS transistor P2 will be on. B is equal to 1. So gate of NMOS transistor N1 is existing at logic 1, so NMOS transistor N1 is on. Gate of PMOS transistor P1 is existing at logic 1, so PMOS transistor P1 is off. Even though N1 is on, as N2 is off, output Z is isolated from ground. Even though P1 is off, as P2 is on, output Z is connected to plus VDD through the on transistor P2. Output Z is existing at plus VDD, or output Z is equal to logic 1. And this is the equivalent circuit of the NAND gate when A is equal to 0 and B is equal to 1. When A is equal to 1 and B is equal to 0. As A is equal to 1, gate of NMOS transistor N2 is existing at logic 1, so NMOS transistor N2 is in the on condition. Gate of PMOS transistor P2 is existing at logic 1, so PMOS transistor P2 will be in the off condition. As B is equal to 0, NMOS transistor N1's gate is existing at logic 0, so NMOS transistor N1 is off. And as gate of PMOS transistor P1 is existing at logic 0, PMOS transistor P1 is on. So even though N2 is on, as N1 is off, output Z is isolated from ground. Even though transistor P2 is off, as P1 is on, output Z is connected to plus VDD through the on transistor P1. So voltage at output Z is equal to plus VDD, or output Z is existing at logic 1. And this is the equivalent circuit of the CMOS NAND gate when A is equal to 1 and B is equal to 0. When A is equal to 1 and B is equal to 1. Gate of NMOS transistors N1 and N2 are existing at logic 1, so both of these two transistors will be on. Gate of PMOS transistor P1 and gate of PMOS transistor P2 is existing at logic 1. So these two transistors are off. As NMOS transistor N1 and N2 are on, output Z is connected to ground. As PMOS transistor P1 and P2 are off, output Z is isolated from plus VDD. As output is connected to ground through the on transistor N1 and N2, voltage at output Z is equal to ground potential, or output is at logic 0. This is the equivalent circuit of the CMOS NAND gate when A is equal to 1 and B is equal to 1. So in the case of a CMOS NAND gate, when any one of the input is equal to 0, output is equal to 1. When both inputs are at logic 1, output is equal to logic 0. Thanks for watching Circuits Analytica. Enjoy learning.